Good morning, my dear students. Welcome to my channel DJ to Learn with Mukesh. So today in this video, we are going to discuss the second chapter of class 9th science, that is your is matter around us pure. So before this, we have already discussed the first chapter of your book, that is matter in our surroundings. If you have not watched the video, you can go to the description and you can watch the video. Now in this video we are going to discuss the summary PPT of the lesson is matter around us pure. In the the next video we will discuss the various question answers from this chapter only. So this is chapter from chemistry. As you know, I have already have told you that your science subject is divided into three categories, that is your physics, chemistry and biology. So here this chapter deals with chemistry, is matter around us pure. Without let, we are now going to discuss the chapter. So first of all, we will see what are the objectives, that means what we will learn from this chapter. First one is, after completion of the chapter, the children will be able to explain types of mixtures and methods of separation of mixtures. Then we will also have knowledge of concentration and types of solutions. Then we can explain about alloys and their significance. Then differentiate between pure substance and mixture. Then finally, we will differentiate between physical and chemical changes. So first of all, what are physical changes? Changes that do not result in the production of a new substance are called physical changes. Means in physical changes, no new products are produced. If you melt a block of ice, you still have H2O at the end of the change. For example, if you take a block of ice, you will melt it, then you still have H2O at the end. The H2O will not change into another substance, so no new substances will be found in physical changes. Another example is there, if you break a bottle, you still have glass only. You will not get any other substances. Next is, some examples of physical changes are melting, freezing, condensing, breaking, crushing, cutting, bending. These are the examples of physical changes. Now we will go for chemical changes. So changes that result in the production of another substance, new substances, those are called chemical changes. So in chemical changes, new substances are produced. As in the case of autumn leaves, in autumn season, the color of leaves changes. This is due to chemical changes. So chemical changes occurs there in the leaves of different trees in autumn season. That's why the color of the leaves changes in autumn season. Next is a half-eaten apple that turns brown. If you cut an apple and you keep the apple outside for a long time, for some time, then you will find that after some time it will become brown. So that also due to chemical changes. Now, on the basis of the physical state, matter is classified into three main types. They are solids, liquids and gases. Already we have discussed in the first chapter. On the basis of chemical composition, matter is classified into two main types. They are pure substances and mixtures. Pure substances are of two types. Again, they are elements and compounds. And mixtures are of two types. They are homogeneous mixtures and heterogeneous mixtures. So, on the basis of chemical composition, matter is classified into two categories. First one is your pure substances and second one is your mixtures. And pure substances are again divided into two categories, elements and compounds, and mixtures are classified into homogeneous and heterogeneous mixtures. Now, pure substance and a mixture. So first of all, everything is divided into two things, matter and energy. So our universe is made up of only two things. First is your matter and second is your energy. So again, under matter, substances are there. Substances are classified into pure substances and mixtures. And again, pure substances are classified into elements and compounds, and the mixtures are classified into homogeneous and heterogeneous mixtures. So first of all, we will see what are pure substances and what are mixtures. Pure substance. Pure substance is a substance which consists of a single type of substance. It may be element or compound. Example, iron, copper, hydrogen, oxygen, water, sugar, common salt, sodium chloride. So these are the pure substances. This only contains single type of substances. In copper, only there is copper. No iron is present over there. No hydrogen is present over there. But mixture is a substance which consists of two or more pure substances. That means the mixture of two or more pure substances is called mixture. There are different pure substances you can find. For example, seawater. In seawater, you will find salt, sodium chloride, you will find H2O, I mean water, hydrogen, oxygen, like that. In minerals also, soil, air, sand and salt, sugar in water, salt in water. These are the mixtures. These are the mixtures of two or more pure substances. When we mix two or more pure substances, we will get a mixture. This is the simple way to express a mixture. Then differences between pure substances mixtures. First difference is pure substance consists of a single type of substance, but mixture consists of two or more pure substances. Pure substance cannot be separated into other substances by physical methods. Mixture can be separated into its components by physical methods. Pure substances has its own definite properties, but mixture shows the properties of its components. For example, if you take salty water, I mean salt in water, then that mixture will show the property of salt as well as the property of water. If you test it, then it will taste salty because the property of salt is present over there. And if you pour it on the ground, it will float from higher position to lower position because it also show the property of water. So salty water shows both the properties of salt as well as water. So mixture shows the properties of both of its components, or whatever the components are there, mixture shows properties of all the components. Now we will come to the next slide, that is pure substances can be divided into two types. First is elements, second is compounds. Then element is a substance which is made up of only one kind of atom. For example, gold, silver, calcium, hydrogen. In gold, there is only gold atom. In silver, there is only silver atom. In calcium, there is only calcium atom. Element is a basic form of matter which cannot be broken down into simpler substances by chemical reaction. So by chemical reaction, we cannot break them into simpler substances because these are the only basic forms of matter. Then elements are made up of one kind of atoms only. Compounds are made up of one kind of molecules only. Next, types of mixtures. Mixtures can also be grouped into different types on the basis of their physical states. It can be divided into solid, liquid and gas. Not that solid, liquid, solid, gas. For example, you see here solid, salt and sugar. Solid, salt is sugar, salt is solid, sugar is solid also. Solid liquid, salt and water, salt is solid and water is liquid. Solid gas, dust in air, dust is solid and air is gas. So solid, liquid, solid, gas. Then next liquid, solid. Mercury is liquid, copper is solid, so liquid, solid. Liquid, liquid. Alcohol and water, alcohol is liquid as well as your water is also liquid. Then liquid gas, cloud is example of a mixture of liquid and gas. Then gas, solid, hydrogen and palladium. Hydrogen is gas, solid is palladium, palladium solid. Next, gas, liquid. Oxygen is your gas and water is liquid. Then air is the mixture of gas and gas. You know there are different gases in air, hydrogen, oxygen, nitrogen, all different gases are there. Then on the basis of miscibility, we can divide them into homogeneous and heterogeneous. Homogeneous, it consists of single phase, and heterogeneous, it consists of two or more phase. In homogeneous, there is uniform composition, and heterogeneous does not have uniform composition. Uniform composition means in every part of the mixture there is same proportion of its what we call when we mix two or more components and the ratio of all the components is same everywhere at any point of the mixture, then that is called uniform composition. Means in every what we call part of the mixture you will find the ratio same. Then example is sugar dissolved in water, and heterogeneous mixture example is air and sand and common salt. If you mix air, sand and common salt, then it will be a heterogeneous mixture. Now again we will discuss more about homogeneous and heterogeneous mixture. So homogeneous is a mixture which has a uniform composition. The particles of the mixture are not visible by the naked eye. Here the particles are not visible by the naked eye. The particles cannot be separated by filtration. The mixture is stable. That means the particles do not settle down. If you keep the mixture for some time, it will not settle down. The path of a beam of light is not visible in the mixture. If you try to pass a beam of light through the mixture, it will not visible. For example, mixture of sugar in water, mixture of salt in water, mixture of copper sulfate in water. These are the examples of homogeneous mixtures. Then we will go for a heterogeneous mixture. This is a mixture which has a non-uniform composition. The particles are very visible by the naked eye. You can see the particles. Then the particles can be separated by filtration. The mixture is unstable. Unstable means the particles settle down after some time. If you keep the mixture without disturbing it, then it will settle down. The path of a beam of light is visible in the mixture. Example, mixture of salt and sand, mixture of sulfur and iron fillings, mixture of oil and water. These are the heterogeneous mixtures. Then we will go for types of solutions. On the basis of size of solute particles, solutions are divided into three categories. First is true solution, second is sol or colloid, and another is your suspension. True solution is homogeneous, colloid is your heterogeneous, and suspension is also heterogeneous. In true solution, size of solute particles is less than 1 nanometer, that is less than 10 to the power minus 9 meter. And in colloid, size of solute particles in between 1 nanometer to 1000 nanometer. In case of suspension, size of solute particles is more than 1000 nanometer. If you go to true solution, then particles cannot pass through the filter paper. In colloid, particles can pass through filter paper. In suspension, particles cannot pass through filter paper. Then true solution is stable. That means it will not settle down if you keep it undisturbed. And colloid stable and settle only on centrifugation. If you do centrifugation, then only they will what we call settle down. Then in suspension, it is unstable and settle down on its own. If you keep it undisturbed, after some time it will settle down. Then true solution, solution of sodium chloride in water, sugar and water. These are examples of true solution. And examples of colloid is your milk and fog. And examples of suspension are muddy water, chalk and water, smoke in the air. These are the examples of suspension. Now we will discuss more about them. First is your true solution. A true solution is a homogeneous mixture of two or more substances. A solution has a solvent and a solute as its components. The component in the larger amount is called the solvent, and the component which is in the lesser amount is called the solute. If you take solution of salt in water, then usually we take more water and we take less salt. So salt is the solute and water is the solvent. Solution of sugar in water, as you know, if you take sugar water, I mean solution of sugar in water, usually we take more water and we take less salt, less sugar. So sugar is the solute and water is the solvent. Iodine in water also. Iodine in water is also called tincture iodine. Then soda water. These are the examples of true solution. Now, what are the properties of true solution? True solution is a homogeneous mixture. That means in every part of the solution, the ratio is the same. Then the particles cannot be seen by the naked eye. The solute particles cannot be separated by filtration. The solute particles do not settle down and the solution is stable. If you keep it undisturbed, then it will not settle down because it is a homogeneous mixture and it is stable. Then the particles do not scatter a beam of light passing through it, and the path of light is not visible in the solution because the solute particles are completely dissolved in the solvent. So through it, the path of light is not visible. It can easily pass through it, right? So it is not visible. Then we come to suspension. A suspension is a heterogeneous mixture in which solute particles do not dissolve but remain suspended through the bulk of the medium. Properties of suspension are: it is a heterogeneous mixture. The particles of suspension can be seen by the naked eye. Then the particles of suspension scatter a beam of light passing through it because the solute particles are not completely dissolved in the solvent. Then the solute particles settle down when a suspension is left undisturbed. So it is unstable. Unstable means when you keep it undisturbed for some time, it will settle down. Next is your suspension. This is a graphical view of suspension. Solute particles can be separated by filtration. You can filter, you can apply the process of filtration. You can what we call separate the solute particles by this process. Then solute particles settle down and the solution is unstable here. Unstable means when you keep it undisturbed, then it will settle down. The particles of solute will be settled down. Then solute particles scatter light and the path of light is visible here. In case of solution, but in case of true solution, no path of light is visible because the light easily passes through it. Now we will go to colloidal solution. A colloidal solution is a heterogeneous mixture of two or more substances. For example, mixture of starch in water, mixture of egg albumin in water, milk, air containing dust and smoke. Milk is the best example of colloidal solution. Next, what are the properties of colloidal solution? Colloidal solution is a heterogeneous mixture. Heterogeneous mixture means not homogeneous. That means in every part of the solution, I mean different part of the solution, there are the ratios are different, right? The particles cannot be seen by the naked eye. The solute particles cannot be separated by filtration. The solute particles do not settle down and the solution is stable. Stable means it will not settle down. Then the particles scatter a beam of light passing through it and the path of light is visible in the solution because the solute particles are not completely dissolved in the solvent. Now, colloidal solution is a heterogeneous mixture. It consists of two phases. First is your dispersed phase, means component present in small proportion, and dispersion medium, that is component present in large proportion. As you know, in a solution, there were two what we call components, solute and solvent. The component which was in larger amount was called what we call solvent, and which was in lesser amount was called solute. Like that, in a colloidal solution, there are also two phases, two components. First one is your dispersed phase, which is present in small proportion, and second one is your dispersion medium, which is present in large proportion. The particles of colloid are large enough to scatter a beam of light passing through it and make its path visible. Thus, they show Tyndall effect. Tyndall effect means when the particles of colloid, so the particles of colloid are large enough to scatter a beam of light passing through it and make its path visible. When you pass a beam of light through it, its path will be visible because the solute particles are not completely dissolved in the solvent particles. So here it will show Tyndall effect. Next is the colloidal particles are moving at random in a zigzag motion in all directions. This type of zigzag motion of colloidal particles is called Brownian movement. This zigzag pattern, the zigzag motion of colloidal particles is also known as Brownian movement. Now, on the basis of amount of solute, we can categorize them into three categories. First one is unsaturated solution, a solution which has a lesser amount of solute that it can be dissolved at a given temperature. That means how much amount of solute a solvent can dissolve in it at a given temperature. If it is lesser amount of solute, that means we can add more solute in the solvent, that is called unsaturated solution because that is not saturated, that can hold more solute. We can add, right? In saturated solution, the solution which is maximum amount of solute that it can dissolve at a given temperature. We cannot add more amount of solute in that solution. That is called saturated because that is saturated. We cannot add more solute in that. Okay. In supersaturated solution, a solution which can dissolve amount of solute by increasing temperature. If we increase the temperature of saturated solution, then it can dissolve more solute, and that is called supersaturated solution. If you increase the temperature, if you heat the saturated solution, then it will be eligible. It can dissolve more solute, and that is at that. No. Now, we will categorize them on the basis of nature of solvent. So, on the basis of nature of solvent, we can categorize them into aqueous solution and non-aqueous solution. The solution in which the solvent is water is known as aqueous solution. So, in a solution, if the solvent is water, then a solution is also called aqueous solution. And the solution in which the solvent is other than water, it may be ether, alcohol, or any other solvent. So, that solution is called non-aqueous solution. Aqueous means with water, non-aqueous means no water is present over there. Then concentration of a solution. The amount, that means mass or volume, you may take in mass or volume, the amount, mass or volume of solute present on a given amount, mass or volume of a solution is called the concentration of the solution. That means in a particular volume or mass of a solution, how much, what amount of mass or volume, what amount of solute is present, that is called the concentration of the solution. So there are three types of ways to express the concentration of the solution. First one is your mass by mass percentage of the solution. Mass by mass percentage of a solution equal to mass of solute by mass of solution multiplied by 100. Mass by volume percentage of a solution equal to mass of solute by volume of solution multiplied by 100. Volume by volume percentage of a solution equal to volume of solute by volume of solution multiplied by 100. So we are going to solve some mathematical questions based upon these formulas in the next video, in which we will discuss various question answers from this chapter. Now, separating the components of a mixture. How can we separate the components of a mixture? The components of a heterogeneous mixture can be separated by simple methods like handpicking, sieving, and winnowing. Okay, and special techniques are also there, like evaporation. A mixture of salt and water or sugar and water, we can follow the method of evaporation. Then centrifugation, butter from curd, fine mud particles suspended in water. Okay, decantation using separating funnel, oil from water. To separate oil from water, we have to follow decantation method, or we can use separating funnel. Then sublimation, camphor from salt. To separate camphor from salt, we can follow sublimation method. Then chromatography, different pigments from an extract of flower petals. Then distillation and fractional distillation, separating components of petroleum. Then magnetic separation, iron pins from sand. We can use simply a magnet, we can separate them, right? So there are different methods, we will discuss one by one. Separating the components of a mixture. The components of a heterogeneous mixture can be separated by simple methods like hand picking, sieving, filtration, etc. Sometimes special techniques are used to separate the components of mixtures like evaporation, centrifugation, decantation, that means using separating funnel, sublimation, centrifugation, chromatography, distillation, and fractional distillation. These are the different methods, right? So first of all, we will discuss evaporation. This method is used for separating a volatile component, that is solvent, from a non-volatile component, that is from solute, by heating the mixture. For example, ink is a mixture of a dye and water. If some ink is heated in a dish, the water evaporates and the dye is left in the dish. Similarly, we can separate the mixture of salt and water or sugar and water by evaporation. Okay, here the solvent must be volatile and the solute must be non-volatile, right? Then centrifugation, the method of separating denser particles and lighter particles from a mixture by using a centrifuging machine is called centrifugation. For example, if we take some milk in a centrifuging machine and spin it rapidly, the cream separates from the milk because cream is less dense than milk, because the density of cream is less than milk. Then decantation, that is using separating funnel. This method is used for separating a mixture of immiscible liquids. Immiscible means the liquids which cannot be mixed. Okay, liquids separate into different layers depending on their densities. Example: if you take a mixture of kerosene, oil, and water in a separating funnel, it forms separate layers of oil and water. The water can be separated by opening the stopcock. After the water flows out of the stopcock, can be closed. After the water flows out of the stop, we can close that. So here only we can separate those liquids which are immiscible. Immiscible means those are those which can't be mixed. They can't mix. Okay, only we can separate them. Then sublimation. This method is used to separate a mixture of a sublimable component from a non-sublimable component by heating the mixture. For example, if a mixture of ammonium chloride and common salt is heated, the ammonium chloride sublimes because ammonium chloride is a volatile substance and can be cooled and solidified and collected, and salt is left behind. So if you take mixture of ammonium chloride and common salt, if you heat, then ammonium chloride will be evaporated. It will be sublimed. Sublime means it will change into vapor state. And after that you can cool it and you can make it again solid form. You can bring it to solid form. Ammonium chloride is a volatile substance, so it can be separated from salt using sublimation method. You know what is sublimation? In the first chapter we have discussed it, right? Then chromatography. This method is used for separating colored components from a liquid by using a filter paper or blotting paper. For example, put a drop of ink near one end of a strip of filter paper and dip the end of the paper in a test tube containing water. Ink is a mixture of two or more colored components. The component which is more soluble in water rises faster and gets separated. So like this, in this way, we can separate. This is called chromatography. Next is your fractional distillation. This is used for separating a mixture of two or more miscible liquids. Miscible means these are this can be got mixed up, right? Whose difference in boiling points is less than 25 Kelvin. The apparatus used for fractional distillation is similar to that used for simple distillation, except that a fractionating column is fitted between the distillation flux and condenser. The only difference between fractional distillation and simple distillation is that in case of fractional distillation, there is a separate fractionating column which is fitted in between the distillation flux and condensation. The fractionating column has glass beads which increases the surface for the vapors to cool and condense. Fractional distillation is used for separating the components of petroleum, separating the different gases from air. Okay. To separate different components from gases, we use fractional distillation, where a fractionating column is fitted between the distillation flux and condensation. Next is your separation of components of air. Air is a mixture of gases, you know. The components of air can be separated by fractional distillation. Air is compressed by increasing the pressure and cooled by decreasing the temperature to get liquid air. So first of all, we have to make it liquid. How can we make it liquid? We have to compress it by increasing the pressure, and again we have to cool it by decreasing the temperature. The liquid air is then allowed to warm up slowly in a fractional distillation column. Then the different components separate at different heights depending on their different boiling points. So first you take air, then compress and cool by increasing pressure and decreasing temperature. Then it will be converted into liquid air. Then allow to warm up the liquid air slowly in fractional distillation column. Then gases get separated at different heights. For example, oxygen will be get separated at 183 degrees Celsius. Argon will be at 186 degrees Celsius. Nitrogen will be at 190 degrees Celsius. Okay. Now, purification of solids by crystallization. Crystallization is the process of obtaining a pure solid in the form of crystals from its solution. For example, by crystallization, we can obtain pure copper sulfate from its solution. So, to get pure solid of crystals from its solution, we apply the method of crystallization. We get the pure solids in the form of crystals. So, this method is called crystallization. Dissolve about 5 grams of copper sulfate in minimum amount of water. Filter the solution to remove the impurities. Evaporate the solution in a china dish to get a saturated solution. Cover the solution with a filter paper and allow it to cool. Pure copper sulfate crystals are formed. In this way, we can separate pure solid in the form of crystals from its solution. As we get the pure solids in the form of crystals, so this method is called crystallization. Next is alloys. A material that has metallic properties and is composed of two or more chemical elements, of which at least one is a metal. This is called alloys. These cannot be separated into their components by physical method. We apply chemical method to separate the components. However, these are considered as mixture because they show the properties of its constituents as kind of variable composition. So alloys have various variable compositions. Here we can separate the components only by using what we call chemical method. By using physical method, we cannot separate them. The benefit of alloys is that you can combine metals that have varying characteristics to create an end product that is stronger, more flexible, or otherwise desirable to manufacturers. So this is the benefit of alloys. We can make the end product stronger, more flexible, and desirable as per the manufacturer. Then use of alloys. Aluminum alloys are extensively used in the production of automotive engine parts. Copper alloys have excellent electrical and thermal performance, good corrosion resistance, high ductility. Okay, we can make what we call wires using that is called ductility, and relatively low cost. Stainless steel alloys are used for many commercial applications such as watch straps, cutlery, etc. Then titanium alloys have high strength, toughness, and stiffness, and are used in aerospace structures. So these are the different uses of alloys. So we discussed the chapter is matter around us pure. So in the next video we are going to discuss various types of question answers from the chapter. So stay tuned for the next video. I will upload it soon. Till then you watch the video, and I think after watching the video you will get a very good summary and very what we call good understanding of the lesson is matter around us pure. In the next video we will meet again with different various type of questions from the same chapter. Till then you enjoy this video. Thank you for watching the video. Have a nice day. Keep learning, keep growing.